Group 15 is the rogues gallery of the periodic table. Why, their name, pnictogens, even comes from the Greek word for suffocation. But suffocation would be the least of your concerns if you crossed paths with any of these deadly chemicals. Nitrogen is everywhere, making up 78% of the Earth's atmosphere. Okay, so maybe it's not deadly, but don't let your guard down just yet. Scuba divers all know nitrogen's most sinister attack. Nitrogen dissolved into the bloodstream can gather into bubbles while returning to the surface. These bubbles cause decompression sickness, also known as the bends, and it can be fatal. Phosphorus is a master of explosives. 4 of them bonded together form white phosphorus, which ignites when exposed to air and lays down a residue of phosphoric acid. Also, fluorophosphate esters are some of the most potent neurotoxins known. Arsenic is toxic to almost all life. Farmers use arsenic and its compounds for herbicides, fungicides, and pesticides. An arsenic compound, known as Agent Blue, was used during the Vietnam War to dry out rice fields and kill the crops. Antimony is poisonous to humans in a way similar to arsenic and can be fatal. Antimony leaches into liquids from polyethylene terephthalate, but I'm sure that this polyethylene terephthalate is an uncommon material you're unlikely to ever come into contact with. Oh dear! Bismuth is, oh my, bismuth is beautiful. No, don't be fooled by its beautiful rainbow crystals. This femme fatale can still be poisonous, primarily to the kidney, liver, and bladder. Still, bismuth is the least toxic of the pnictogens. Fortunately, ununhexium cannot be produced in large amounts, but its short half-life means that it would be very radioactive, but only briefly, attacking quickly before disappearing.
Hi and Assalamualaikum everyone. Today we are from Group 9, are going to present the Group 15 binary compounds, and these are all my group members. I'm going to be starting with the nitrites and azides. What is actually nitrites and azides? Nitrites and azides are the nitrogen that forms simple binary compounds with other elements, and they are classified as nitrites and azides. Nitrites. There are 3 types of nitrites. First is selenitrites, covalent nitrites, interstitial nitrites. So, the selenitrites, it can be regarded as containing the nitrile ions, and it has high negative charge of it, which means they are highly polarizable and likely to have considerable covalent character. They actually usually occur for the lithium nitride and group 2 element nitride. Next, covalent nitrides. They are called as covalent nitride because the En bond is covalent. They possess a wide range of properties depending on the element to which the N is bonded. For example, bor nitride, cyanogen, phosphorus nitride, and so on. The third one is interstitial nitrides, which is the largest category of nitrides of the D block elements with a formula of Mn, M2n, and M4n. The N atom occupies some or all of the octahedral site within the cubic or hexagonal close-packed lattice of metal atoms. They are hard and inert, with a metallic luster and conductivity, and widely used as refractory materials, and find applications as crucible, high-temperature reaction, and thermocouple sheath. Next, nitrite ion. These are all the properties of nitrite ion, which are often found as a ligand in D metal complexes, high negative charge, small size, has the ability to serve as a good pi donor and as well as the sigma donor, where it can stabilize metal in high oxidation states. The Mn bond represents the short coordinate bond between the ion and the metal atom. So this is an example of the Mn bond molecule. Now we continue with azides. Azides is toxic and unstable. It is used as detonators in explosive. Azide ion form many metal complexes, and the nitrogen is present that may be synthesized with the oxidation of sodium amide with either nitrogen oxide or nitrogen dioxide. These are the equations. The average oxidation number of N in the azide ion is -1/3. The ion is isoelectronic with both dinitrogen oxide, which are nitrogen dioxide and carbon dioxide. These molecules are linear. It is a strong Bronsted base, the pKa of its conjugate base, hydrazoic acid HN3. It is also a good ligand towards D-block ions. However, heavy metal complexes or salts such as PbN32 and HgN32 are shock-sensitive detonators and decompose to produce the metal and the nitrogen. The last one is ionic azides. So the example of ionic azide is sodium azide. It is thermodynamically unstable and kinetically inert, which they can be handled at room temperature. Sodium azide is toxic and is used as chemical preservative and in pest control. When alkali metal azides are heated or detonated by the impact, they explode and liberate nitrogen gas. This reaction is used in the inflation of airbags in cars, in which the heating of the azide is electrical. That is all from me, and I'll be passing to my next friend for the next presentation. Thank you.
Well, my name is Hu Jiahuan, and now I'm going to explain about phosphide, which is one of the group 15 elements. So phosphide is a compound containing P3 negative ion, and there are many different phosphide comes with differing structures. But the most common structure that we usually will use is binary phosphide. So here's the definition of binary phosphide, which is those materials only consist of phosphorus and a less electronegativity element. So we have the examples such as sodium phosphide, aluminum phosphide, and calcium phosphide. So to prepare phosphide, we have different ways, but the common way we use is by heating a metal and a red phosphorus in a vacuum or under an inert atmospheric condition. So all the metal phosphide can be synthesized from the elemental phosphorus and the respective metal element in stoichiometric form. Well, now phosphide can be separated into three types, which is metal-rich phosphide, monophosphide, and phosphorus-rich phosphide. So for the metal-rich phosphide, as we know, metal-rich meaning that the percentage of the metal is going to be higher than the phosphorus. So the ratio of M and P is greater than 1. While the phosphorus-rich phosphide, meaning that the percentage of the phosphorus is higher than the metal, so the M ratio P is lesser than 1. But for monophosphide, since their ratio, the percentage is same, so we just write it equals to 1, right? Here's the properties of metal-rich phosphide. It is inert, hard, and brittle, and they are refractory materials. And also don't forget, they are a good conductor for heat and electricity. Well, next let's proceed to phosphorus-rich phosphide. So for the phosphorus-rich phosphide, they have lower melting point since they have less percentage of metal. Okay, and they are less stable compared to metal-rich phosphide and monophosphide. Also, they are semiconductors. Okay, next let's proceed to monophosphide. So monophosphide that adopts a variety structures depending on the relative size of the atom. So here's the example again. So for aluminium phosphide, they adopt a zinc blende structure. So here's the aluminium phosphide, and this is their structure. Okay, right. So that's all from me. That's all for my presentation. Thank you for listening.
My name is Nurfara Natasha, and I'm going to explain to you guys about arsenides, antimonides, and bismuthite. Let's get to know on this binary compound. So this is the physical properties of arsenic and antimonium bismuth. We can see atomic number increasing up. Same goes to atomic mass and their electronic configuration that have valence electron 5 and their electronegativity lowering when moving down the group. And also the melting point that we can see here, arsenic have the highest compared to antimonium bismuth because of the metallic nature occur between them that makes the interaction between electrons become poor. And also boiling point due to the size of these three elements and binary compounds that vary to each other. So the bismuth have the highest boiling point because of the most big size. Now let's take a look with the physical and chemical properties of arsenides. So arsenic is a bright metalloid which its outermost electrons cannot move freely in the structure which is crystal because of the position already fixed in covalent bond. So basically arsenic is a metalloid which formed by the covalent bond. So it is also a metallic, luster and brittle. It looks like a shine and bright metallic, class as metalloid or semi-metals, half metal and also half non-metal, exists in three allotropic form as crystalline but in three different color, which is yellow, black and grey, and the grey allotrop is the most common use out there. It also a highly poisonous metalloid, so the uses of this binary compounds are very restricted and have appropriate and proper instruction. Has a high density, moderate thermal conductivity, and the ability to conduct electricity is very limited because of their character itself, metalloid. Dissolve in oxidizing acids, burns in pure oxygen if ignited, and can act as acidic and basic, which is amphoteric. So this is the synthesis of arsenides. Generally, arsenic can be found naturally in the ores, which is the rock that contain valuable minerals such as realga, orpiment, arsenolite, and arsenopyrite. Arsenic can extracted from the flue dust of copper and also lead smelters. By heating the ores, without the oxygen also, we manage to get arsenic. For instance, in this reaction, the ores that are being used is arsenopyrite, heating under 700 degrees Celsius to form ferrous sulfide, then arsenic in gas state. We can conclude that arsenic in gas state deposit as arsenic in solids, which can then be used to make another compounds. Another method that can also be used to get the arsenic is the reduction between arsenic trioxide with carbon dioxide. The uses of arsenides can be seen in communication as a dopant in solid-state devices such as integrated circuits, mobile phone, laser, optical window, and radar. While in agricultural field, it used as insecticides to control the pests and in other poisons. It also used as essential trace elements to lead the active growth for chickens, rats, goats, and pigs. Arsenic is used as a pyrotechnic hardening and improving the versatility of shot and embossing. Gallium arsenide is used in lasers which convert electricity into coherent light. In medical field, arsenic trioxide used as anti-leukemia drug. Now we're going to move to another binary compound, which is antimonides. This is a physical and chemical properties of antimonides. It is a metalloid, same just like arsenides, exhibits allotropy, and the most stable allotrop is the metallic form. It looks a luster and brittle metallic. Have high density, moderate thermal conductivity, and a limited ability to conduct electricity. Can act both as an acid and also a base, which is amphoteric, and have several oxidation states of antimony are +3, -3, and +5. React with oxygen only when heated. This is the synthesis of antimonides. Mainly, antimony is obtained from its sulfide ores and it vaporized under the low temperatures. By heating the ore stibnite with iron, antimony is extracted, which producing the metal and iron sulfide. And the metal is the antimonides itself. Is antimonides used for? Commonly, it used in alloys with desirable properties for electrodes in lead-acid batteries. It also produces semiconductor materials such as gallium arsenides, gallium antimonides, and indium antimonide in electronic devices. Produce infrared detectors and light-emitting diodes. And antimony oxides increase the activity of chlorinated hydrocarbon flame retardant. Okay, I'm going to explain about the bismuthides. So this is the physical and chemical properties of bismuthides. First is a post-transition element, metal like tin and lead, has recently been found to be a radioactive element. And also a poor metal, poor electrical conductor, and also poor thermal conductivity since it is a metal that being in transition element. It also have the lowest electronegativity and ionization energy, which it means that it has a lower attraction of electron. It also burn with a blue flame and clouds of yellow oxide when heated in air and have several oxidation states which are +3 and +5. Then, how bismuthite is produced? So usually it found as the sulfide ores, often in combination with sulfide of other heavy elements such as copper, silver, and lead. That means that bismuthides can be found when it combined with another elements. Bismuths occur as a bismite and bismuthinides. Bismuth also is obtained as a byproduct of the refining of other metals, allowing other metals to recycle their byproduct into bismuths. These are some applications of bismuthides in daily life. Here we can see bismuth tin alloy used as a replacement in shot and bullets instead of lead. While in nuclear reactor, it used to make transuranium elements using a process called cold fusion. Then it also form alloys with low melting point that can be used in fire detectors and extinguishers if fire burn out in building. It also used as a catalyst to speed up the manufacturing process of synthetic fiber and rubber. While in medicine, bismuth subsalicylate with conjunction with antibiotics, treatment for peptic ulcer stomach, HS and diarrhea, and also bismuth trioxide as a hemorrhoid creams. Bismuth also been used in cosmetic product, which is bismuth oxychloride, and bismuth oxide. A bismuth compound is used as a yellow pigment in paint.
Hi and good morning everyone. My name is Muhammad Nakib bin Muhammad Hussein. My metric number is 207640. Hydrides. So nitrogen hydrides are binary compound of hydrogen with nitrogen atom, which is group 15 elements covalently bonded to hydrogen. So for your information, all EH3 hydrides are all toxic. I'm going to explain more details about ammonia, hydroxine and hydroxylamine, and lastly phosphine, arsine, and stibine. Ammonia. Ammonia is a compound of nitrogen and hydrogen with chemical formula NH3. It is a primary source of most nitrogen-containing compound, and it is used as a production of fertilizer. Ammonia present in two states, which is liquid state and solid state. Liquid state, which is liquid ammonia, is used as non-aqueous solvent solute. For example, alcohol, amines, ammonium salt, amides, and cyanates. Ammonium salts such as ammonium sulfide is used as fertilizer for plant. Okay, the physical properties of ammonia is it is colorless gas and with a pungent smell. The chemical properties of ammonia are it is soluble in water and soluble in solution of salt of strong acid. Okay, ammonia can be synthesized using Haber process in the presence of iron as a catalyst with 140 degrees Celsius and pressure at 180 m. So this is the chemical equation for reaction between nitrogen gas with hydrogen gas to form ammonia. Okay, this is the structure of chemical structure of ammonia. Nitrogen atom which bonded with 3 hydrogen atom. Okay, so we're going to proceed on hydroxine and hydroxylamine. Okay, hydroxine with chemical formula N2H4. It is fuming colorless liquid odor like an ammonia. It is used as a foam blowing agent, treatment in boiler water to scavenge dissolved oxygen and prevent oxidation of pipes. It can be synthesized using Raschig process by ammonia and sodium hypochlorite reaction dilute aqueous solution. Okay, this is the chemical reaction. NH3 plus NaCl will form NH2Cl plus NaOH. So 2NH3 plus NH2Cl will form N2H4, which is the hydroxine, plus NH4Cl. So this is the chemical structure for hydroxine with 2 nitrogen bonded with 4 hydrogen atom. So we're going to proceed on hydroxylamine with chemical formula NH2OH. Okay, it is colorless, hygroscopic solid, low melting point, and form of salt and form of aqueous solution. Okay, this compound is used to synthesis of caprolactam, which is the intermediate in the manufacture of nylon. Okay, hydroxylamine can be synthesized by adding sodium butoxide to a hydroxylamine hydrochloride. Okay, this is the chemical reaction NH3OH ClSO4 plus NaOBu will form NH2OH, which is the hydroxylamine, plus NaCl plus BuOH. Okay, so this is the chemical structure between for hydroxylamine, which is N bonded to 2 hydrogen atom and bonded with hydroxide atom ion. Okay, so we're going to proceed with phosphine, arsine, stibane, and stibane. Okay, we're going to focus on phosphine first. Phosphine with chemical formula pH3. The properties of this phosphine is it is colorless, flammable, and very toxic gas compound. It is used as a dopant in the semiconductor industry and a precursor for the deposition of compound semiconductors. Okay, phosphine can be synthesized use the disproportionation of white phosphorus in basic situation. Okay, this is a chemical reaction for phosphine, which is P4 plus 3OH minus plus 3H2O will form PH3, which is the phosphine PH3 plus 3H2. Okay, this is the structure, chemical structure of phosphine, which is a P atom bonded with 3 hydrogen atom. Okay, so we're going to proceed with arsine with chemical formula ASH3. The properties of this arsenic, it is flammable, highly toxic gas, it is colorless, denser than air, slightly soluble in water and in many organic solvents, and it is an odorless gas. Okay. It is used in the synthesis of semiconducting material related to microelectronic and solid-state laser. Okay, arsenic can be prepared or can be synthesized by photolysis of compound that contain electropositive metal with arsenic or antimony. Okay, this is the chemical equation to synthesize arsenic, which is Zn3E2 plus 6H3O plus will form EH3 plus 3Zn2 plus 6H2O. Okay, this EH3 is we can substitute E with AS, so AsH3 is a form of arsenic. Okay, we're going to proceed on stibine, which with chemical formula SbH3. The properties of this stibine is colorless gas, has an offensive smell, slightly soluble in water and insoluble in solvent. Okay, this stibine is used in the semiconductor industry to dope silicon to prepare other semiconductor compound. Okay, stibine can be synthesized by prepared by photolysis of compound that contain electropositive metal with arsenic or antimony. Okay, this is the chemical equation for synthesis of stibine with Zn3E2 plus 6H3O plus will form EH3 plus 3Zn2 plus 6H2O. Okay, this EH3 is a we can substitute Sb with E, so we will get SbH3. As we can look here, this reaction and this reaction is the same reaction. That's why we put this as E in the chemical reaction, because the process to synthesize this both binary compound is the same. Okay, that's all from me and our group.